Yeah, good morning. We have another example of Lagrangian, and corresponding to this Lagrangian, we have to obtain the Lagrangian equation of motion. So, for a given, in this example, we have a profile of L, which is ax dot square by 4 and by dot square by 4 minus kxy, where x dot is, where AB is constant and x dot is simply dx by dt and y dot is simply dy dt, means velocity along x and y direction. Now we have to set up a Lagrangian equation of motion corresponding to this Lagrangian. So again we have to check how many number of generalized coordinates. In this, what is our job? Our first task is to recognize how many number of generalized coordinates present in this system. So number of generalized coordinates qk, which is x and y. So generalized coordinate is, we have two generalized coordinates. So how many number of Lagrangian equation of motion corresponding to this dynamical system whose Lagrangian is, this is 2. So we have two different set of Lagrangian equation of motion. So one is, so we have a general profile of Lagrangian equation of motion, which is del L upon del qk dot minus del L upon del qk equal to 0. Now we have two different generalized coordinates. So corresponding to these two different generalized coordinates, we have to set up two different Lagrangian equation of motion. So for x coordinate, our Lagrangian equation of motion is simply d by dt of del L by del x dot minus del L by del x equal to 0. So what is del L by del x? We will simply find out del L by del x and del L by del x dot. So del L by del x is simply del by del x of L, which is ax dot square by 4 plus by dot square by 4 minus kxy. So this is equal to, if it again differentiating partially with respect to x, so there is no term. So there is x dot, there is y dot. If we differentiate partially with respect to x, this will give 0, this will give 0, and this will have some value, and what is that value is simply minus ky, because partially if we differentiate, this x gives 1. And what is del L upon del x dot? Del L upon del x dot, again differentiating our Lagrangian partially with respect to x dot. So x dot square by 4 plus by dot square by 4 minus kxy. So there is only one term in dot, in x dot. So this x dot is twice x dot. So what we have finally, and this will 0, this will 0, because we are differentiating partially with respect to x dot, and this will give us ax dot by 2, twice of x dot square becomes twice of x dot, and 2 will cancel out this 4, so we have only 2 here. Now putting the value of del x by dot, del L by del x dot, del L by del x in this equation. So what we have d by dt of ax dot by 2 minus del L by del x is minus ky. So ky becomes 0. So what we have simply ax dx by dt is again. So this will becomes, let me write one more step. So this is a by 2 dx dot by dt plus ky equal to 0. This is the differential. So dx dot by dt is again x double dot. So ax double dot by 2 plus k of y is equal to 0. This is Lagrangian equation of motion for x generalized coordinate. So this double dot means this is rate of change of velocity, and this will acceleration. Double dot means d2x by dt square. So this is the way to set up a Lagrangian. Now we have a Lagrangian in y. We have generalized coordinate in y. Our qk is x and y. Our qk is in x and y. So we have two different generalized coordinates. So correspondingly we have two different set of Lagrangian equation of motion. One is this and the is this. So for y coordinate we have Lagrangian equation of motion. Lagrangian equation of motion is simply d by dt of del y. Now we are in y coordinate, and del y equal to 0. Again differentiating partially with respect to del L by del y is simply minus k of x. Differentiating this L partially with respect to y. So we have only one term y. So this y becomes 1. We have minus kx. Now del L upon, what is our del L upon del y dot? It means differentiating this Lagrangian partially with respect to y dot. So we have only one term of y dot. So this y dot square is 2y dot, and 2 will cancel out. What we have? We have simply by dot by 2. By dot by 2. Now putting the value of this del L by del y dot and del L by del y in this Lagrangian equation of motion. So what we have now, putting the value of del L by del y and del L by del y dot in above equation. So we have d by dt of del L by del y simply by dot by 2 minus k of x equal to 0. This can be written as b by 2 dy dot by dt plus kx of x. This is rate of change of velocity in y direction. So this can be written as y double dot. So by double dot by 2 plus kx of g. So this is Lagrangian equation of motion for y coordinates. So again we have a lot of information about this equation of motion, that our Lagrangian is in x and y, means our Lagrangian having two generalized coordinates. So our qk is 2, so degree of freedom is 2, and Lagrangian equation of motion is 2. So you can formulate lot of objective questions from these questions, because there are several ways to ask questions. That is, how many number of generalized coordinate in this Lagrangian, what is the degree of freedom corresponding to this dynamical system whose Lagrangian is this, how many number of Lagrangian equation of motion, how many number of Lagrangian equation of motion. So corresponding this Lagrangian we have two different Lagrangian equation of motion, because this is a conservative system. So we have basically two Lagrange equation of motion. So it's all about this examples. We have another example. We have another example in which the Lagrangian of a particle of mass m. So the Lagrangian of a system is given as 1 by 2 m a square theta dot square plus omega square sin square theta plus mga cos theta. obtain Lagrangian equation of motion. Obtain Lagrangian equation of motion. So again, in order to set up a Lagrangian equation of motion, which is second order partial differential equation, so we have to recognize that, we have to identify that how many number of generalized coordinate present in our Lagrangian. So the first step, recognize or identify number of generalized coordinate. If it is 1, then we have to set up only one Lagrangian equation of motion. In earlier case, we have two generalized coordinates. That is why we have to set up two different Lagrangian equation of motion. So in this case, we have only one generalized coordinate, which is theta. So correspondingly, we have to set up only one Lagrangian equation of motion. So Lagrangian equation of motion is simply d by dt of del L by del qk dot. So our qk is theta only. So this is theta minus del L by del theta, which is equal to 0. So what is del L by del theta? Is simply del by del theta of 1 by 2 m a square theta square plus omega square sin square theta plus mga cos theta. Now differentiating partially with respect to theta. So we have two different term of theta. One is sin, one is cos. So this and this will give 0. So what we have? We have 1 by 2 m a square omega square, this is 0, omega square sin square theta is 2 sin theta and cos theta plus mga, cos is minus sin, so plus there is minus. So this is our, and this 2 and this 2 will cancel out. So what we have? We have simply ma square omega square sin theta cos theta minus mga sin theta. This is our del L by del theta. What is our del L by del theta dot? So our Lagrangian, in this expression we have only one theta dot term. So if we differentiate partially with respect to theta dot, this will give twice theta dot. And we have ma square. So 1 by 2 ma square, this is twice theta dot plus 0 plus 0. So this 2 will cancel out, and what we have? Simply ma square theta dot. Now putting the value of del L by del theta and del L by del theta dot in Lagrangian equation of motion, LEOM, which is d by dt of del L by del theta dot is simply ma square theta dot and this one, which is ma square omega square sin theta cos theta minus mga sin theta, which is equal to 0. And this m is a constant, a is constant. So only variable in this Lagrangian is theta and theta dot. If you are going to set up a differential equation, mass and a is, g is also constant, mass is constant, a is constant. So differentiating, this is ma square d theta t by dt, so which is theta double dot, because we know that this is theta dot is simply d by dt of theta dot is d theta dot by dt, which is theta double dot. This is just a convention. So we can, instead of writing d theta dot by dt, we can express our acceleration in terms of theta double dot. So that is why this is ma square omega square sin theta cos theta plus mga sin theta is equal to 0. This is the Lagrangian equation of motion corresponding to this Lagrangian equation of motion corresponding to this Lagrange. So I think I have explained 2 to 3 examples to understand the concept of Lagrangian equation of motion for a given Lagrangian. So now we are enough confident that we can set up our differential equation of motion, Lagrangian differential equation of motion for given any L. Whatever be the profile of Lagrangian, we can directly set up our Lagrangian equation of motion, and it depends upon the number of generalized coordinates present in our Lagrangian system. In earlier case we have 2 generalized coordinates, so we have to set up 2 different equation of motion. In this case we have only one generalized coordinate, that is theta. That is why we have to set up only one Lagrangian equation of motion. And the solution of this Lagrangian equation, I will discuss it later on, that the solution, this is second order partial differential equation. So in next lecture we will focus, or we will discuss on the solution of second order partial differential equation or second order Lagrangian equation of motion. And the solution of this Lagrangian equation of motion will give us the trajectory of our dynamical system or mechanics of our dynamical system. So it's all about the Lagrangian equation of motion. Thank you.